So before we get into our lesson, which at the bottom in purple is 2.5 graphs of rational functions, I have 3 true-false questions for you. Why don't you go ahead and pause the video and answer these 3 questions and see if you got them right. All right, so number 1, I can divide 0 by a non-zero number. Let's think about what that means. So I can divide 0 divided by a non-zero number. So any number, we'll say 2. Or I could write that as 0 over 2. They mean the same thing. Well, can I do that? Yeah, I can. And I will always get 0, no matter what that other number is. As long as the other number is not 0, I'm always going to get 0. So, true. I can divide a non-zero number by 0. A non-zero number, basically I'm switching it. Say 2 divided by 0, or 2 over 0. Well, what does that give me? I cannot divide by 0. If I plug in my calculator, I get an error. What I'm really getting is like infinity. So we're going to go with false. Okay. And then lastly, can I divide 0 by 0? 0 divided by 0, which would be 0 over 0. And this one is, well, just no. False. If you ask Siri 0 divided by 0, I don't know if she still does anymore, but she used to have this fun example about having 0 cookies and 0 friends to share with your 0 cookies or whatever. So anyway, the point is I cannot divide by 0, but depending on what I'm trying to divide by 0, I actually get 2 different things. So if I'm dividing some non-zero number by 0, I get infinity. If I divide 0 by 0, we get kind of like just a black hole kind of deal. It's just an omitted point or some kind of empty space. We'll talk about that in a little bit. So today we are talking about rational functions. Rational functions, let me go back, slide. Rational means ratio or fraction. So when you see that right there, rational, we're going to think a fraction. So if you remember from our parent functions, our parent function was 1 over x. Now we're going to get more complicated looking than that, but the point is that there'll be a fraction and there's going to be an x or multiple x's in the denominator. Might be in the numerator too, but there's got to be at least 1 x in the denominator. They end up making some interesting looking graphs, right? So in blue, in the top right hand corner, you'll see this was the equation, fraction, you see x in the denominator, and this is the equation it makes. All right. Now, the red dotted line is an imaginary line that they kind of graph on there to show you something. But you see how it illustrates a pattern. As your blue lines go to the far left and the far right, they get closer and closer to that line. They never touch it, but they're going to get closer and closer to that line. That line is called a horizontal, because it's side to side, asymptote. Asymptote, for our purposes right now, is the line that gets closer and closer and closer to. When we get to calculus, we'll learn a little bit different definition for asymptotes. But for right now, it's the line that my graph gets closer and closer to. It never actually touches. Now, we have 3 types of asymptotes. We have our horizontal asymptote. Another one we're going to have is a vertical asymptote. This particular graph actually has 2 vertical asymptotes. This one is located right about there. So there's a vertical asymptote. And if I come over here, there, right about, is a vertical asymptote. You see how if my graph goes up or down, those are my vertical asymptotes. Okay. Here we see some more, and we're going to see our 3rd kind of asymptotes. But let's start on the one on the left. We see that red dotted line. That's a vertical asymptote, right? But horizontal asymptote would be, oops, I thought I was on the line tool. Try that again. This right here would be my horizontal asymptote. So it has one vertical and one horizontal. If I come over here to the one on the right, we see it shows me my vertical asymptote. But then we don't have a horizontal asymptote. We have this right here. And this is neither vertical nor horizontal. It's called a diagonal asymptote. All right, so three types: horizontal asymptote, vertical asymptote, and then we have a diagonal asymptote. Okay, and in part two, we're going to look at how do I know when I have each one. A little bit of a spoiler alert. So go back, look at these. This one says I have a horizontal asymptote at 2. Notice right here, 2 divided by 1, 2. It works in some cases, and you'll learn why just in part 2. I come over here. My horizontal asymptote, again's at 2. 4 divided by 2, 2. But over here, we have a diagonal asymptote. We have 1 and 1. 1 divided by 1 is 1, but that's not where our horizontal asymptote is. So again, part 2, we'll talk about our cases and how we find all of those different asymptotes.